All right, let's dive into something that's puzzled some of the greatest minds.
Hmm.
Probability. You've asked for a philosopher's perspective on this, so we're going deep into the Stanford Encyclopedia of Philosophy's entry on interpretations of probability. It's pretty heady stuff, but, that's what we do here, make it fascinating and digestible.
And fascinating, it is even the seemingly simple question like, what is probability?
Hmm.
Leads to a whole rabbit hole of philosophical debate.
Right, we toss the word around all the time.
Yeah.
Election predictions, chances of rain, even a simple coin flip, but pinning down what we mean by probable. Bertrand Russell himself famously quipped, probability is the most important concept in modern science, especially as nobody has the slightest notion what it means. So that's got to pique your curiosity a little bit, right?
It certainly does. The source highlights just how varied these contexts are where we use, probability. But to even start untangling this, I think we need some kind of framework. And thankfully, we have Kolmogorov's axioms of
Wait,
probabilities.
axioms don't lose me already.
No worries. No worries. Think of them as the ground rules for how we work with probabilities, almost like a mathematical grammar. It's not about the philosophy yet, but it establishes the structure for how we calculate and manipulate probabilities, which is surprisingly powerful.
Okay, so there's order beneath the chaos. That's reassuring. But if these are the rules, what game are we even playing? The source outlines kind of three main concepts of probability, which is a good starting point, I think.
Absolutely. First, we have epistemological probability, and this focuses on how strongly evidence supports a belief. It's about our knowledge, not necessarily some intrinsic property of the event itself.
So like if seismologists say an earthquake is probable, we're talking about how much their data, the seismic activity, fault lines, all that backs up. They claim their confidence level based on what they know.
Precisely. Then there's subjective probability, which is all about an individual's degree of belief regardless of the evidence. So that gut feeling you have that it'll rain, even though the forecast says sunny.
So this is where philosophy really digs in. Two people with the same info can have wildly different subjective probabilities. It makes you wonder about rationality.
Yeah.
How we should update our beliefs.
Yeah.
Have we opened Pandora's box here?
Indeed. And lastly, we have physical probability focusing on propensities or tendencies inherent in the world itself.
Okay.
Radioactive decay in atom has a certain probability of decaying seemingly independent of our knowledge or beliefs about it.
Okay. Three ways to slice this probability pie, how it relates to our knowledge, our personal confidence, and the world's inherent tendencies. So let's dig into how philosophers have actually tried to interpret these.
The most intuitive at first, I think, is the classical interpretation, and it kind of boils down to everything being equally likely outcomes. Dice rolls, coin flips, situations that are, designed to be symmetrical.
Right, so the standard six-sided die, each face has a 16 chance. Simple probability pie equals slices.
Exactly. It works great in games of chance, but it quickly runs into limits, and that's where Bertrand's paradoxes come in, showing how this seemingly straightforward idea leads to contradictions.
I remember the source had an example with cubes, right? It's something about side links and areas.
Precisely. Imagine a factory making cubes with sides between 0 and 1 foot. What's the probability a random cube has a side between 0 and ½ foot? Classically, it seems like half assuming a uniform distribution.
Makes sense to me.
But what if we ask about the probability of a random cube having a face area between 0 and 0 square foot?
Now I'm thinking overassume a uniform distribution of areas.
Right, and we can keep going. What's the probability the cube has a volume between 0 and cubic foot?
Well, by that logic, but wait, it's the same cube. How could it have three different probabilities for the same event?
That's the paradox. The principle of indifference, of assuming equal probabilities when we lack specific info, breaks down and depends on how we frame the problem, even if the underlying reality is the same.
So our intuitive equal slices idea crumbles when we're dealing with continuous variables and different ways of measuring things. What's next on our philosophical tour?
The logical interpretation, championed by Carnap and others, tries to move beyond this. It seeks to define probability based on the logical relationship between evidence and a hypothesis, even when things aren't so neatly symmetrical.
So instead of just counting outcomes, we're looking at the inherent logic connecting evidence and what we conclude from it.
Precisely. It's an attempt to systematize inductive reasoning itself, to quantify the strength of that connection. Carnap even tried building formal languages for this, with probability assigned to statements within those languages.
Now that sounds complicated.
The gist is he focused on what are called state descriptions, basically the most complete descriptions possible within a given language, and he argued that more homogeneous state descriptions should have higher probability.
So if we're describing apples and they're all red, that's a more probable state than one where they're mixed red and blue, like uniformity is more likely, which kind of fits our intuition about generalizing from similar observations.
Exactly. But there are immediate objections why favor uniformity, and doesn't the choice of language itself influence the probabilities, making it less objective?
It's like trying to build a perfectly logical tower, but the ground keeps shifting underneath. The quest for objective probability continues.
Indeed, and that leads us to an interpretation that leans into the subjectivity we've been wrestling with, the subjective view of probability.
All right, let's embrace the subjectivity then. If it's all about an individual's degree of belief, how do we even make sense of it rationally?
One approach is what's called the betting analysis, linking your belief to your willingness to wager on an event. Your confidence level is reflected in the odds you'd accept for a bet.
So if I'm really sure my team will win, I'll take a bad bet because I think I'll win anyway.
Precisely. But of course, betting behavior isn't always purely rational. People get caught up in the thrill or might bet against their beliefs for strategic reasons.
Plus, placing a bet could change my belief, especially if it's a high-stakes game. Suddenly I'm sweating, even though I was super confident before.
Exactly. So it's more nuanced. We might look at what odds someone considers fair, even if they don't bet, as representing their true belief. It's about that point where they see no advantage to either side.
Okay, so we're probing their internal sense of balance, not just their gambling habits. But this brings up the bigger issue of how beliefs and desires and rational choices all intertwine.
And that's where decision theory comes in, going beyond just isolated probabilities. It's about how those probabilities interact with our values and goals to drive our choices.
So if I'm debating taking an umbrella, my belief about rain probability mixes with my desire to stay dry utility.
Exactly. There are even formal frameworks for this, like expected utility, where we aim to maximize the average value of our choices, considering both the desirability of outcomes and their probability.
But even this fancy framework has its limits,
Hmm.
right? Humans aren't always that calculated, and sometimes our emotions just hijack our best laid plans.
Absolutely. It's a model, not a perfect reflection of reality, and it raises deeper questions. Can we truly separate our beliefs from our desires?
Mhm.
Are there any rules for rational belief beyond just internal consistency? Or can a subjectivist believe pretty much anything as long as it doesn't contradict itself?
Well, that's a question for part 2 of our deep dive. Stay tuned as we explore how philosophers try to wrangle subjective probability into something a little less arbitrary.
Welcome back to our exploration of probability. Last time we were kind of wrestling with this subjective view, questioning if there are any limits to rational belief beyond just mere consistency. After all, you could have a perfectly consistent set of beliefs that are also totally outlandish.
Right, like believing I'm going to win the lottery and get struck by lightning and discover a new species of penguin all in the same day.
Mm.
Internally consistent, maybe, but not exactly grounded in reality. So how do we reel in this subjective freedom?
One idea is this concept of regularity. It says that a rational person should assign at least some non-zero probability to any proposition that's possible, at least in principle.
Hold on. So if I say there's absolutely zero chance I'll win the lottery, even though someone technically could, I'm being irrational, but come on, some things are so unlikely.
That's the pushback, right? Where's the line between, healthy skepticism and shutting down possibilities completely? Regularity kind of suggests being open to being wrong, even about things that seem wildly improbable.
I can see the point, but it feels like a slippery slope. Should I assign non-zero probability to spontaneously developing telekinesis just because it's conceivable?
That's the debate, right? How much structure do we impose on rational belief? Regularity is one attempt. But let's look at another calibration. This checks how well our beliefs line up with actual frequencies of events in the real world.
Okay, so if I constantly say there's a 70% chance of rain, but it only rains 40% of the time, my internal weatherman is badly calibrated.
Precisely, it's about comparing your subjective probabilities to the real-world track record. Like, if your gut feeling is consistently wrong, maybe it's time to adjust how you form those feelings.
Makes sense. It's about fine-tuning our intuition based on feedback, but we can't always neatly categorize events and count their frequency, right? What about one-off things like predicting who will win a specific election?
You've hit on the limitations. The 2020 election, for example, was unique. It's hard to talk about calibrating your belief to its frequency when it only happened once. Same with predicting if I'll win a particular lottery. It's boom or bust, no long-term pattern to compare to.
So calibration is helpful, but it doesn't solve everything. Are there other ways to ground our beliefs beyond being internally consistent or vaguely matching real-world patterns?
This brings us to expert functions. Think about it. We rely on experts all the time to guide our beliefs. We trust our doctor's assessment of a treatment success rate or a financial advisor's prediction of market trends.
No, this hits home. Last year, I had to decide about a somewhat risky medical procedure, and the doctor said it had an 80% success rate. And to be honest, I just latched onto that number. I had no idea how to calculate it myself, but I
But
trusted her expertise.
that's exactly it. We defer to experts because we believe they have a better grasp of the relevant probabilities, a more accurate internal model than our own. We're essentially treating their probability function as an expert function.
So I was basically saying, Doctor, you're the expert. I'll adopt your probability as my own. Which raises the question, is there some universal expert function out there applicable to everyone?
There is a contender, one we've touched on already, relative frequencies. The principle of direct probability suggests that, in a sense, these frequencies should be a guide for all rational people.
So if we observe that historically event X happens 60% of the time,
Hmm.
all rational folks should incorporate that into their beliefs.
Precisely, relative frequencies provide a kind of objective anchor for subjective probabilities, but we run into the same issues as before, which reference class to use how to handle unique events. Those problems don't just disappear.
So the quest for a one-size-fits-all probability guru continues. But there's another contender we haven't discussed yet, objective chance.
Ah, yes, this one gets deep. It's often linked to propensities, which are like dispositions towards certain outcomes, but there's a subtle difference.
And remind me, propensities are like that loaded die, right? Where the weighting isn't obvious, but it makes some sides more likely.
Exactly, but propensities are often thought of as causal. Objective chance, however, is about fundamental indeterminacy, a randomness that might not be reducible to cause and effect.
Okay, this is where my brain starts to hurt. So if I flip a truly fair coin, it's not just that the coin is disposed to land heads 50% of the time. It's that there's an objective 50-50 chance for this particular flip, even though nothing causes it to land one way or the other.
Precisely, objective chance is a deeper level of randomness potentially woven into the fabric of reality itself.
All right, I think I'm barely grasping that. So how do we connect this objective chance with our subjective beliefs? Should knowing the objective chance of something force us to believe it'll happen that way?
That's where what's called the principle comes in, formulated by David Lewis. Put simply, if you know the objective chance of an event and you have no other relevant information, your degree of belief should match that chance.
So if I know a fair coin has a 50-50 objective chance and I have no reason to suspect this specific coin is rigged, I should believe it'll land heads with 50% confidence.
Exactly. It's an attempt to bridge the objective and subjective, saying our beliefs should be guided by these fundamental probabilities when we know them, which is rarely the case.
Right back to those pesky problems, what counts as relevant information, and what about unique events that don't seem to have an objective chance attached to them?
Deep questions indeed, like other attempts to ground belief. The principle has its critics, but there's one more approach we need to discuss. One that ties chance to the very structure of scientific theories, the best systems interpretation.
Ooh, that sounds like we're going to meta. Explain it to me like I'm a philosophy student cramming for finals.
Imagine we're building the best possible scientific theory of the universe. We want it elegant, powerful, and to accurately predict what we observe.
So like Occam's razor simpler is better, but it also has to work.
Exactly. This interpretation says that chances are the probabilities baked into our best scientific theory.
So if our best physics theory says particle X has a 30% chance of decaying, that's the objective chance, not just a description of that specific particle.
Precisely, chances aren't just about individual events. They're part of the universe's blueprint, as reflected in our best attempts to understand it.
This feels more solid. No need to worry about reference classes or one-off events.
Yeah.
But it relies on us having the right theory, doesn't it?
Yeah.
What if our best is just our current best guess and the universe is far weirder?
Excellent point. This interpretation has its critics. Is it circular, defining chance by our theories, which might themselves be probabilistic? Is it too human-centered? What if the universe doesn't care about our ideas of elegance?
Even when we try to be objective, those subjective shadows creep back in so much for escaping the philosophical maze.
Not so fast. There's one more twist, a more recent interpretation that's even more mind-bending. It involves looking at how probability can arise, even in systems that are completely deterministic.
Right, deterministic. I thought probability was all about randomness. How can you have chance when everything is predetermined? This I got to hear. But unfortunately, that's going to have to wait for the final part of our deep dive. Welcome back for the final act of our probability play. We've journeyed through interpretations that ground chance in logic, subjective beliefs, even the structure of the universe itself. But you left us hanging with a real head-scratcher. How can probability exist in a system where everything is predetermined? That seems like a paradox.
It does, doesn't it? We naturally associate probability with randomness, with that sense of could go either way. But this final interpretation really challenges that very notion.
So remind me, what's this mind-bending idea called again?
It's called the method of arbitrary functions, and it's a way to understand how probabilities can emerge even within deterministic systems where, in principle, everything is set from the start.
Okay, I'm all ears, but color me skeptical.
Yeah.
We square this circle.
Well, it hinges on a concept we've touched on before, chaos. Chaotic systems are those that are incredibly sensitive to their initial conditions. Tiny variations at the beginning can cascade into wildly different outcomes.
Like that butterfly flapping its wings and causing a hurricane across the world, right? The butterfly effect.
Exactly. The butterfly effect is a popular illustration of chaos in such systems, even though the underlying laws governing them might be completely deterministic. Their sensitivity makes them practically unpredictable.
So even if there's no true randomness in the laws themselves, the system behaves as if there were, just because we can't perfectly account for all those tiny starting variations.
Precisely. It's a kind of epistemic randomness related to our knowledge, not necessarily to how the world fundamentally is. Our predictions are limited not by the laws themselves, but by our ability to measure with absolute precision.
Okay, so it's not that the roulette wheel itself is random, but that my ability to know where the ball will land is limited by a gazillion tiny factors I can't possibly measure. Makes sense, but it still feels weird to call that probability.
And that's where the method of arbitrary functions gets a little technical. It provides a mathematical way to quantify this epistemic randomness under certain conditions. Even in a deterministic system, we can assign probabilities to outcomes, reflecting not chance in the universe, but the limits of our knowledge.
So it's like saying determinism and probability aren't mortal enemies. After all, depending on the system's complexity, we might need probability to describe our experience of it, even if the underlying reality is perfectly set. That's kind of freeing in a way.
It is. It challenges a lot of our assumptions about how these concepts relate. Probability may be more fundamental than we thought, emerging not just from randomness out there, but also from the intricate dance between deterministic laws and our very human inability to know everything perfectly.
Okay, I think I'm starting to get a glimpse of this, but doesn't this kind of blur the lines between objective and subjective interpretations? Kind of both, isn't it?
You're spot on. On one hand, the probabilities derived from this method are grounded in the system's objective features, its laws and sensitivity, but they also inherently reflect our subjective limitations, our inability to measure with infinite precision.
So it's objective in what it's describing about the system,
Yeah.
but subjective in how much we can ever know about it.
Yeah.
Probability becomes this bridge between the world as it is and our limited grasp of it.
Exactly. It highlights that probability isn't just about chance occurrences. It's also deeply entangled with knowledge predictability and the very act of making sense of the universe.
Wow, what a journey this has been. From intuitive notions of chance to formal rules to these wild philosophical interpretations. It's clear we've just scratched the surface of what probability is and what it means.
And each attempt to define it just opens up more questions. It's almost as if the more we grasp for it, the more it slips through our fingers. But that's the allure of philosophy, isn't it? The pursuit itself is as valuable as any final answer.
Absolutely huge. Thanks for taking us on this deep dive.
Yeah.
It's been challenging, but truly mind-expanding. So where do we go from here? What's the takeaway for our listeners who followed us down this rabbit hole?
I think the key is recognizing that these various interpretations aren't necessarily mutually exclusive. They might be different lenses, each revealing something unique about this complex concept we call probability, rather than searching for the right answer. Maybe it's about understanding how each perspective illuminates a different facet of how chance, knowledge, and the universe intertwine.
Well said. So to leave everyone with something to ponder,
Mm-hmm.
I have to ask about that final thought you mentioned last time.
Ah, yes, the
Yeah.
simulation question. It's a bit of a thought experiment. If we could perfectly simulate our universe down to the last detail, would that simulated universe have the same probabilities as ours? Would the virtual coin flips land the same way?
Now, that's a question to keep you up at night. It
Yeah.
really cuts to the heart of what probability is. Is it baked into reality itself, or is it an emergent property of our limited perspective, something that even a perfect simulation couldn't truly replicate?
Yeah. I don't have the answer, but I encourage everyone to wrestle with it. It might just spark your own deep dive into the mysteries of probability.
Thanks for listening, everyone, and until next time, keep those philosophical gears turning.